So input S, let's take it as anagram. T is Nagaram. And we'll define public Boolean is anagram function which takes two strings, string S and string T. And we're going to declare use an integer array called table equal to new integer array with 26 characters, the size of the input array. Why? Because there are exactly 26 alphabets or letters, 26 letters in the English alphabet. So the main idea is we're going to subtract the character in string S from A and increment that index position in the table array, which will be the difference between the ASCII values of A and whatever the letter that's in string S. And then we are going to decrement while we are iterating through T the value at that specific index in the table. And when it becomes 0 exactly, that means the frequencies of the letters in S and T match and they are the same, and it's a valid anagram. If they don't match, if for some value of the letter it goes below 0, that means we have a problem. It is not a valid anagram. So let us look at the pseudocode and the algorithm. So for int I equal to 0, I less than s dot length, I plus plus, we're saying table of s dot character at I minus a. We're going to increment it. So when I take a minus a, so I'm incrementing the index at 0th position to 1. So that means the difference between the ASCII values of a and a will give me 0. So that's the first letter in the English alphabet, A, and it will be at the first index, that is 0. And then what I'm going to do is I'm going to declare another for loop and initialize a index j equal to 0, j less than t dot length j plus plus, and I'm saying table of t dot character at j minus a, and I'm going to decrement this. So every time I am iterating to t, I'm going to get the letter and I'm going to decrement the value at that specific index in the table. So if it exactly matches S and T frequencies for that letter, this will always remain 0. If it goes below 0 when we are subtracting, we're doing a decrement, that means the letters, frequencies of letters mismatch and it is not a valid anagram. So we're going to check that here. If table of t comma character at A minus A, if it becomes 0 at any point, we're going to return false. Else, we're going to return true. That means the letters in S and T, the frequencies exactly match, and T is a valid anagram. This is a Java implementation of the valid anagram logic for lowercase English letters. Let us look when the input letters are in Unicode. For example, let us take the